Welcome everyone to EECE 492. In this class we're going to have several videos. There's going to be lots of videos as part of the class. One thing I've found though is I hate editing videos. So if I record a video and then I have to go back and edit it, it's like hours of work for the video. So instead of doing that, most of the videos I do this year, I'm going to use basically streaming software. So it's all going to kind of be edited live as I go along. So this one is like that. I have a microscope. I have different views that I'll be using. Give me feedback. I don't usually do these. I don't know what people look for in these, but hopefully this works out okay. I have some control. If the video, I found I've had to go to software encoding to encode these videos at this resolution. My computer's video card sucks, but the CPU is pretty good. So, but we're pretty much kind of close to maxing out the CPU because it's doing that software encoding. And I don't know, I might get a different video card later. But the purpose of this video today is to show you how to create a circuit board that has prototype components, that has footprints for prototype components. You're all going to have to submit prototype components or PCB this week. That's parts for your board. So, so this is going to be an important video for you to watch, to pay attention to. A lot of this is just going to be practical considerations for limitations we have within this program. This is not sort of like a general, when you go out into industry, this is what you're going to do. This is more what you need to get things done this quarter in this class alone. So don't read too much into this. And if you're watching this video from outside of our program at Western, if you found this on YouTube, then it's probably not going to add much value to you. This is sort of how to cheaply fabricate a circuit board in a way that you can send it off to the cheap Chinese fabs and get it made. And so you have multiple components on one single circuit board. So to get started, we're just in Altium here. It's already open. So all the process of loading, installing, and exporting is all going to be in separate videos. This one's just about putting multiple components in a useful format on a board. So we're just going to first create a new project. And I'm going to call this Proto pieces, and we're going to use the 2-layer PCB project template. That's the default Western created template, and it's going to save, and this is important to pay attention to, this is just going to save into my default documents folder for Altium. A lot of you might want to save this to your user drive or something like that. I'm going to create that. So I always like to start on the board side of things when I'm doing something like this. So I'm going to start on the board layer. And I'm first going to get my outline. So the maximum size we can do for these circuit boards, if we want to keep these cheap, the maximum size we can do is 100 millimeters. But sometimes the export kind of gets thrown off. So I kind of like to set it to about 99 millimeters. So the first thing I like to do is just create a square for my own just visualization of the sort of maximum dimensions of the outside of this board. So I'm going to just pick a mechanical layer. Maybe I'll pick mechanical 12. That seems to be a popular one. And I'm going to place a line here. And I'm going to set, first of all, right now our units are mil, so I'm going to hit the Q key, change that to millimeter. I'm going to hit the G key, and I'm going to set my grid to 1 millimeter. And then now what I'm going to do is just anywhere, I'm going to click, here. And I'm looking at that top left corner, and I just want to draw up, I want to get a 99 millimeter grid vertically. And then 99 over. Oops. And then, oops. Gotta double click that when we're in this setting. And that should be negative 99. And then, okay. So that's sort of my outline. I'm just doing control scroll, zoom in here. So if we want to make this the actual outline of the board, and I don't know if this is the size we're going to end up wanting to fabricate or not. If we want to make this the actual outline of the board, we can click on one of these and do find similar objects. And we can select everything that's this same mechanical 12 that I just created. And we can say it's a track, but we can say this is any. There shouldn't be anything that's on mechanical 12 other than these tracks. And click apply, and that's going to select the outline of that we just created. And then from that, I can go to design, board shape, define board shape from selected objects. Now that's going to redefine our board to be just this area in here. You'll notice it goes, oh, as I scroll, the grid kind of came back to me here, so that's kind of nice to do. All right, so this is sort of let's make sure we're not going to go bigger than we can, because when you submit these files, if you submit a file that's bigger than 100 millimeters by 100 millimeters and the fab says we can't do it, what they'll say is we can do it, but it's going to cost $40 instead of $5. And normally what that means is we won't do that. I mean, we're not going to, just because you were off by a millimeter, we're not going to pay 8 times as much. But the bigger issue is it's going to delay the order for all of your classmates. So when you submit these, you really want to make sure they're under 100 millimeter by 100 millimeter. You will get points off if it doesn't follow the requirements, and it'll delay your order, and it'll delay your peers. So you really want to make sure you submit something that's valid ahead of time that you know is going to be correct. Okay, so now we have the general shape on here. Let's go back to our schematic. Go back to it as our first time. So you should set all of these values if you're doing this. I'm going to skip it for this video. There's other videos where I show how to set these, and I'm just going to find random parts. So this is just an example of you're doing a design. There's parts you want to use, but you need a prototype with these parts. You don't necessarily have the PCBs that will allow you to prototype for those yet. You might have some weird footprint stuff. So this is going to show sort of how to do that. So I'm just kind of just picking random components here. The new LTM has this manufacturer parts search. I'm going to find some stuff. Let's see if we do. I probably should have thought about this more. So let's do a AT Tiny, a microcontroller that I know is going to be small. Okay, so we'll find that AT Tiny. It's kind of a interesting little microcontroller here by Atmel. All right, let's do this one. So let's right click, we'll go place, and we're gonna this is moving very fluidly, so I'm gonna hit the G key so I'm on a grid. Hit it again. Look at that bottom left corner. Where grid's at 100 mil now. That's good. I'm gonna place this here. And now looking at this thing, 1, 2, 3, 4, 5, 6 pins on this thing. And probably what we're going to want to do is we're probably going to want to have a, 3 pins on each side is typical. We could have 6 pins on one side. I'm guessing this footprint, actually I want to see what this thing looks like first. So I'm going to just annotate it. And actually there's a quick annotate in LTM now. So we do that. So annotated is U1. We'll do design, update PCB. Okay, so here's our part. Yeah, so it's a little 6-pin thing. So if I'm going to create a pins, we can't just, even if we get our part on this footprint, it's not going to necessarily work for us. We need to make a connection to it with jumper wires on our breadboard. So we're going to have pins on this thing too. So we're going to have to add headers to actually make a pin connection here. So I'm going to go back and I'm going to go to components. If components doesn't show up, you can go down to the panels button in the bottom right corner and select components and make it show up again. So if you lose something, and I think by default now in Altium, the components is not used. They try to really push you to that part search. So if the component's not used, yeah, you can do that. So, so let's find one. Okay, so we want to go to header. Oops, not devices, connectors, miscellaneous connectors, and this is one of the default things. So if we want a 3 pins, if we're going to make 3 pins on each side, we're going to want a header 3. Let's scroll down and make sure that looks okay. That looks pretty good to me. Right click, place, and we can just put these near it. They don't need to really be necessarily aligned. And I'm going to show you the way when I have something like this where I'm just prototyping something, I'm going to show you what I usually do to label these things. So I don't like to have wires stringing around all over the place. So what I'm going to do now is I'm going to extend wires out from each of these pins. And I'm now going to label each one of these. And so to make sure we don't have duplicate labels on our design, this is part U1. It's already been annotated. I am going to label this. I hit tab to go over to that. So I'm just going to label this signal U1 P1. I'm going to drop that there. And I'm also going to drop, so now it automatically advanced to U1 P2. That's kind of nice. So we're going to have to make sure we go to pin 2, right? This is pin 1, this is pin 2. So, you know, the pins are not always in order on a schematic document. Pin 3, pin 4, pin 5, and pin 6. Okay. And now we can hit escape and we can go back and we can do, oops. Oh, let's go back to our net label. We can hit tab, not escape. Go back to U1 P1. And then now we can place it here. So we could do U1 P1, P2, P3, P4, P5, P6. And we might have to kind of play some games with these headers. We'll see when we get in there. We're going to hit escape. Now we're going to re-annotate, annotate schematics quietly, update our PCB document. Okay, so now it tossed our headers on here. Okay, so now the nice thing is these headers right now are all sort of aligned with the pins, right? So I had to rotate them and move them around. It's a little weird. These have a square, you know, usually a square designates pin 1, which is useful here. So it would be nice if we used a header that didn't have a square on this side. It doesn't really matter in this particular case though, so it's not going to be a huge deal. I'm going to show you a couple options that we have. The first thing we want to do though, when we drop headers down for a part, is we want to make sure that these are dip aligned. So the dip standard is 0.1 inch spacing on the grid. The dip standard is that a spine of a breadboard has a 0.3 inch gap. So we're going to make sure that's all set before we move any further. So to do that, we're going to hit the G key. We're going to change our grid to 100 mil. We're going to hit the Q key. Right now we're still in millimeters. We're going to hit the Q key to go back to mil. So now all we have to do, because our grid is set to 100 millimeters, it's pretty easy to sort of to know when we're getting off, right? To know when we're misaligned. It's going to be pretty obvious on this grid what's misaligned and what's not. So right now, this part has, it looks like if we click here and then look at our delta X, yeah, so we're 400 mil across. So this is further across than a spine. So if we use this right now to make a part that was cut out and put on a breadboard, this part would be, there would be a row of, or a column of pins that's unused that's under this part. So 0.3 millimeters to bridge, that's hole to hole across the spine of a breadboard is 0.3 millimeters, or sorry, yeah, sorry, 0.3 inches. We're at 0.4, so we'd be jumping over a row. We'd have an extra row. Sometimes we need to do that just for space. We don't necessarily have to do that here. We can probably fit this in if we wanted to. I am inclined not to push it though. So if we have an extra row on our breadboard, that's fine. We might not even want to use this part for a breadboard. But we could very easily do. If we wanted to fit this in, I would move this part back here to get the spacing correct. And then it says there's no violations here because that's funny because it collides with the proper pin, so there's no actual violations right now. We could technically just do it like this. We're not going to. So if we just set our grid a little bit different, we could set our grid to like 20 mil. That'll let us move this smoothly. And let's set our grid to 25. See if we can catch a cleaner middle. That looks pretty good, yeah. So now this would actually work. Actually, let's just do it like this. That works good. When we're breadboarding something, it doesn't necessarily matter, like the names don't really have much meaning to us. So the P1, P2 and stuff, I'm going to actually get rid of those. Oops. So you can just hide it like that. Double click it, hide the designator. Double click it, hide the designator. But what you might want to do is, for your own benefit, you might want to label this thing. A lot of times labeling it on the back is still useful, so that's probably a good idea. You want to make sure pin 1 is indicated one way or another. So right now we have a pin 1 indicator on the part. It might be good to also add one to the headers here. Another thing that we could do alternatively on the headers, if we had more space here, is we could actually write the names of the pins on the inside of the header. So let's just do that. Actually, we'll do that on a different one. I'll duplicate this, put it on a separate one. So for now, all we have to do for this is route it up. Oh boy. My computer lagged here. And the thickness is going to depend on your design. So, normally we might want to do thicker traces than this, depending on what we're looking for. That's fine though. This will work for now. Okay, so for this one, that's good. Make sure our grid is set to 100 millimeters. Okay, now the question is, how big do you want to make these parts? One issue with these parts is if the board extends too far, you're not going to be able to access the holes on the breadboard. So if the board extends too far, it's not going to be very useful for, you're going to be covering holes next to your board when it's plugged into a breadboard. So you kind of want to keep it a little tight. But the other issue is we're putting a lot of parts on one board. So when we're putting a lot of parts on one board, we're going to have to cut those parts out in between. So the perimeter of each part is going to kind of be set by how we cut it. And we have to set this up to cut it. So on that, and we'll get to that a little bit later, but there's some special considerations for how much space do we leave in between parts when we're doing that. But for the edge of the board, for this part that's going on the edge of the board, we actually want this to be fairly close. So I'm going to set my grid here to set it to 20 mil or something like that. And then set it to 5 mil. Okay, so that's pretty good. That's looking pretty good right here. Okay, I'm going to show something else that you can do though. So we did this one. Let's call it good. Let's save. So let's say I want to do another one of this. I'm going to show you a slightly different way to do one of these. So I can take all of this, and one downside is you can't. It's not easy to copy, paste, and change values in this software. So it's not necessarily super easy to just take this and duplicate it and have everything stay the same. It's easy enough though. So I'm just going to select all of this, copy, paste. So now the problem is now we have two U2s. So what I'm going to do is I'm going to take this back and I'm going to do U question mark. This one's going to be P question mark. This one's going to be P question mark. The names, though, we're kind of in trouble. So we basically, for the names, we just have to delete all of these. Now we're going to do design, tools, annotation, annotate schematics quietly. Okay, so now I made this U2, which is what I was assuming it was going to do, made this P3 and P4, and it has a memory here. This U1, it keeps a memory of the part that we copied and pasted. And so now we're just going to do the same thing we did over here, just new labels. So we're going to do net labels tab. So there's going to be U2, P1, 2, P1. So that's pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, 2P1, P1, P2, P3, P4, P5. Okay, so there's something else I want to do. So a lot of times if you have like a microcontroller or a part that's like a microcontroller, quite often they require decoupling capacitors to be very close. And the issue when you're breadboarding something is you can't get anything close to, oh sorry, when you're prototyping a part, you know, any signal that connects to that part has to go through these header pins, through jumper wires, through whatever else. There's a lot of things that don't play nice with that. So like if you're doing a regulator, like a switching regulator, a buck or a boost regulator, the feedback circuits on those, all of those should be implemented on your actual PCB, because if you try to implement a feedback network on a boost regulator outside the PCB, it's going to have enormous noise. It's going to be way too big a traces, way too big a distance. So quite often when you're doing PCB prototypes, when you're doing these little prototype pieces, you have to implement some of the circuit on the actual part itself. So we're going to do that here. We're going to put a capacitor on here. I'm also going to show, hopefully, a way to sort of improve our footprint here. So first thing, though, I'm going to update the PCB document, just so we can get our eyes on this thing. Oops. Accidentally selected my outline there. Okay. So we'll put this up here. So the first thing I want to do is, I notice these pins look a little tight. So it looks to me, and if I switch to 3D view, it's not that great. So, you know, it's going to be tough to solder these by hand. So my question is, and I haven't checked this before I did this, do I have a better footprint? So we can go to preference, oops, we can double click this to go to the properties and go to footprints. Yeah, so there's several footprints here. Usually these are like low density, medium density, whatever, and I don't know. So a lot of times you'll see these labeled 1, 2, 3, like sometimes it'll be large, small, medium. Sometimes it'll be high density, low density, medium density. I don't know the N and the L and stuff. My guess is, though, this L is going to be a lower density, so my guess is the pads are going to be bigger. We can show it. We can look at these. So, oh, I think I guessed wrong. Yep, so that's got bigger pads. So it looks like M has the biggest pads. And it can kind of be hard to tell. These are a little wider, so I think these are probably narrow. So these are probably narrower pads. You know, depends on your fabrication process. That's fine. Let's just use these. I don't know if that's what it had by default. Maybe that's... Okay, so we have to update our PCB document again if that made a change. Nope, it doesn't know what it changed. Maybe it already was set to M. Well, let's do this one. That'll change the footprint. Okay, so now you see, yeah, now we have two different footprints. So the same part, we're using two different footprints though. Personally, I would almost want these pins to be even longer if I were doing it myself, but let's just start throwing stuff in place. Set our grid to 100. For now, we'll just move this here. We'll move this. I know this one's going to take up more space, so just right off the bat, we're going to do a bigger space here. Looks like this one has to be rotated. Okay, perfect. So, all right. So if I start deleting these things, sometimes it puts them back when we re-annotate. But all right, so I want a capacitor on this thing too. So I want a decoupling capacitor between VCC and ground. So I'm going to place a component. So I'm going to go to miscellaneous devices. We're going to go to, I believe it's, we need an 0603 capacitor. Yeah, 0603. There we go. Okay. Replace that. And the size, whatever. We'll say, you know, this doesn't actually change the footprint. We'll just say 1 microfarad. I don't know what it needs to be. And so now we want this connected between VCC and ground. So it's easy enough. The problem is we don't really have a ground, and we don't want to call something ground because we're going to have a lot of components on this board. So this other side of this, which is connected to ground, needs to be set to U2P1. And if I hold down the shift key, change the value there. Sorry, U2P2. So U2P2 is ground. That's what we have to connect here to this bottom pin. We might want to have extended that out, but so we need to re-annotate because that capacitor is changed. Update the PCB document. Okay, so now we have our capacitor. Okay. I'm going to do a couple of things on this one. So let's give ourselves even more space. Space that out. Set our grid to something like 20 so I can actually move this around. Okay. So oops. And removing these is something you can do after the fact. I mean, it's something you can do on all the parts after the fact if you want. So you can, you know, if you're doing a bunch, you can just leave them, and then at the very end, you can just turn off. You can just select everything and turn off the visualization of the part. So I'm going to do a couple things different with this one, but I'm going to start off by kind of routing this as best I can. And actually, you know what? I want to do this here. Yeah, and actually, I can keep this a little bit tighter. Okay, that looks good. Everything's nice and balanced. All right, let's go back to routing. And we'll set our grid somewhere reasonable. Okay, now moving that capacitor down there, now what I can do is, if I want, set my grid really tiny and set this to 6 mil. And sneak this in here. And some people don't like to have exits that look like that. Oops. Let's try to be a little symmetrical here. Sort of, close enough. So some people don't like corner exits, and that's fine. If you know, and that's probably bad the way I have this thing done right here. So if you want, you can be a little more reasonable here. I don't know what's going on there. It doesn't wanna... There we go. Okay. So now we have a decoupling cap in here as part of it. Everything's kind of grid aligned. So what I'm going to do now also is I'm going to label this thing. So I'm going to label. There's not a lot of space. Well, we might be able to label it on the top on this particular one. But we can also label it on the back if we want to just make it really easy on ourselves. So we can do view, board, oops, flip board. And then if we do place, string. We're going to change, we're going to mirror it. We're going to do our text height to about the smallest we can go, which is 30. Stroke width of 6. And so what I'm going to do now, and not going to be top layer, it's going to be bottom overlay. So what we can do now is we can see, we got to remember, we're looking at the mirror image here. So pin 1 is here. So if we go back and we look at what was pin 1 was PB0. But sometimes there's got other stuff that we care about, but we'll call it PB0. Oh, weird. It shows how's my stream doing? CPU. Oh, CPU is only at 15%. Good for me. So we're going to change this to PB0 and put that here. Now we're working on the back side here. I'm going to set my grid to 25 mil just to keep it kind of organized here. PB0. Pin 2. What's pin 2? Okay, so pin 2 was ground. Oops. And for now, I'm just going to place these other ones, and then we'll change the values of them later. I don't like that. Actually, one thing we can do, so we can set the snap grid, snap grid X, I'm going to set to 5 mil. And then snap grid Y, I'm going to set 25 mil, and that's going to let us get a finer, it's going to keep us aligned with the pin there, but it's going to let us get closer to that side. It's going to get it closer to balance with the other side of the board. Okay, let's just go back to okay, so now we got to change these pins though. So pin 3 was PB1. Pin 4 was, let's try to do a lot. Pin 4 was PB2. Pin 5 was VCC. Let's see, 1, 2, 3, 4. I think this is PB3. Okay, so now on the back of this board, we're going to have labels for all of our pins. And let's just make sure pin 6, PB3, yeah, okay. Okay, so on the back of this board, we're going to have labels for all of our pins. We have our capacitor. Okay, now let's flip back to the other side of our board. Actually, let's view this in 3D just to make sure it all looks good. Yep, looks pretty good. Okay, let's go back here. So, now we need to get this thing aligned. So, we already have one part. We already have one part here. So we already have one part. Now the question is, how close do we want this next part to get? So this is where how we remove these parts matters. So you can cut these with a bandsaw if you want. That's pretty narrow, but it's kind of a little rough. We have a clean way of doing these parts, and that is to use. So if you use this thing, so this is you can see it's got a little blade that sticks out that when you pull the levers, it kind of pulls the blade in. So if you're using this on a circuit board, and I have an example circuit board here, what it does is it nibbles into the board. You put it up here and you do that and it leaves a little notch, right? So let's, if we switch to the old fancy microscope view here. All right, so that was the notch that it just nibbled out. And we can keep doing that. Right, so we can go into that notch, nibble it again, and it gives us a relatively clean way. It's a little slow. Oops. But it gives us a relatively clean way to cut a channel out of our PCBs. Yeah, I'm kind of skewing. I'm kind of trying to do three things at the same time here. But so this, oops, is a fairly clean cut into our circuit board. It's not a bad way to do it. If you want to avoid going into a shop and getting a bandsaw, it's not a bad way to do it. So if this is how we want to do it, then we need to leave a space for this channel. And this channel is 6 millimeters. So the blade in this thing cuts 6 millimeters. We generally want to make sure we have a little bit of extra space beyond that. So one thing we can do, if this is the idea that we're going with, is we can leave 6 millimeters of space around all of these parts as we place them. So this corner part doesn't necessarily matter so much. But for, oops. Oops, I didn't. You were on a different view than me. So this part in the corner, it's fine in the corner, but we want to make sure that anything that's next to it has enough buffer that we're able to nibble these things out. So to do that, I'm just going to do a 6 millimeter channel around, a 6 millimeter groove sort of around my part. So what I'm going to do is I'm going to select this whole part and just move it off to the side here. And now I'm going to just draw, just with the silk screen, a border around this thing that is about 6 millimeters. So I'm going to draw the, oopsies, set my layer to top overlay. So whatever size I want this thing to be, you know, I probably don't want this thing to be too big, so I probably just want it to be like this. Now I want to do another space around this, which is 6 millimeters. So one thing I can do is, you know, right now my units are in, you know, imperial, not metric. But if I switch to metric, it'll switch my view to metric while keeping my snap grid imperial. So I can kind of see. It looks like, okay, so 6 millimeters is what I need. That's what I said, right? Is that right? Yeah, 6 millimeters is what I need. So that's about, if we switch back, yeah, 250 mils. So let's set our grid to 50 mils. Let's move this thing so that it's grid aligned again. So 250 mils of buffer around this thing is going to be 1, 2, 3, 4, 5 of these. So let's place more. Place a line. 1, 2, 3, 3, 4, 5. 1, 2, 3, 4, 5. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so now this looks ridiculous, right? I mean, this is a huge space around this part. But that's why you got to be really careful when you're doing this, because the amount of space you need around parts is deceptive. We're really zoomed in here. We're operating, you know, we're operating in zoomed in land, even though this thing looks small in the real world. on a circuit board, it's actually fairly large. It's a fairly large channel that this thing cuts out. So now with that 6mm barrier around this thing, I can take this entire part, and now I can move this to, you know, this part itself is all grid aligned. So if I set my grid even to something tiny like 5, it's going to be fine. All right, so this would be okay, you know, this would be okay as a part on a circuit board. I would be able to cut in between these parts. If I wanted to actually have this thing, I mean, if I wanted to have this thing at the top, it doesn't even need a top space. But if I was trying to do this like at the corner like this, and I had other parts in here, I'm going to want to, those parts on the edge can stay in there, but I need to keep around each of my components this sort of buffer space. So what we could do then as we're doing this is we could just keep on adding these, you know, as we add a part, if it's adjacent to another part, we add a 6mm buffer, and it'll allow us to do this. If you want to use a bandsaw, it can be a little bit more narrow. If you have a different tool, you know, a lot of times little cutoff wheels, little tile saws are things people will use. Just remember, this is fiberglass, so you can't just cut it with any old thing. It needs, it will wear down most blades for most things, so you want to be a little careful. So this is the technique I show. I'll probably do another video that gives some extra little tips about this kind of thing. This is a little different than panelization, so you'll see a lot of things on panelization. That's not really what we're trying to do here. Another thing I want to talk about briefly is a lot of times you'll see boards and they do, when they have these parts that are separated like this, they'll do drill hits that are sort of right next to each other. So they'll do a bunch of drills, so it only leaves a little tiny hair's width of fiberglass in between those drills, and it allows you to sort of break them apart by hand. Most fabs don't like it if you do that. So if you know the fab and you know they're okay with that, that's one thing you can do to make breakaway boards. You know, where you will cut a channel between the components and then just leave a little, you know, a couple little, you know, adjacent drill holes holding it together. That can be really dicey though. If you do that wrong, it's going to be a giant headache for the fab, because as they're trying to make it, your board is too fragile for it to hold together. So unless you know they're going to be okay with that, you're better off doing a solid board with components that are spaced out, so you can cut them out later, either using a tool like this or doing something else. I guess we can zoom on to me. So either using a tool like this or using a saw or something like that. But the main thing is you need to make sure you have the appropriate space, and you need to make sure it's appropriate, even when you're zoomed in your Altium view, that you make sure you're very clear-headed about the actual size you need between these parts. So I'll probably show an example of sort of a finished board, or a board that has a bunch of components that are all spaced out. But this is if you are fabricating, even if you're just doing multiple components on the same board, this is a good way to do it. You can also, ignoring the schematic, if you did the schematic for one, it is possible also to, to mess absolutely everything up. It is possible to take a part and copy it and then paste it. Oops. So you can do this, where you copy. So if you want to make multiple copies of a part, you can do this. Altium does not like this though, right? There's this method of copying and pasting a part and traces. It should be easy with other EDA softwares. It's easy. With Altium, it's not. So if you want to make 7 copies of a certain footprint for a chip, as a last step, you can do it. You can make a bunch of them. You can export it for fab, and it'll be okay. But you do it as a last step because it doesn't play nice with Altium. So if we take this and we do update schematics, it throws a fit. Right? So extra components, it doesn't know what to do with it. It doesn't know how to generate extra components in the schematic. So it's not going to like it, but if you need to make multiple parts, this is an option too. Okay, thank you everybody.